Hello everyone, welcome back. So in this video we are going to understand a very important question from the Leetcode is ways to express an integer as a sum of power. Okay, so this is Leetcode problem 2787 and the question is very important because it is saying to return the number of ways n can be expressed as a sum of x. Means let's suppose we have given n, we have given is 160 and x equal to 3. Means if we want to find the n with the sum of some numbers in the power form 2, let's suppose, so 2 to the power 3 means because x is 3, right? So it is saying 2 to the power 3, 3 to the power 3 and so on till we'll go, right, until we'll not receive your sum is equal to 160. Okay, 160. That is why the question is saying that we have to return the number of ways that n can be expressed as the sum of x power of unique positive integers. So we have to take unique positive integers and their power should be x. If we'll do the sum, right, how many ways we can do the sum and we can get 160, like the n we can get, that number of ways we have to return, right? So in other words, it is saying the number of sets of the unique integers, right? Let's suppose from n1 n2 and so on we have, right, till nk, where n equal to n1 n2 in the power, right, n1 to the power x, n to the power x, until we'll call n k to the power x. If we'll do all the sum, we'll get n. So what you have given, think very first you have given two things. The n we have given is 10 and x we have given is 2. Means we have given n we have given and x we have given, right? So you must count how many sets of distinct positive integers we have, right? Means if you see the number of sets of unique integers, right, from n1 n2 and nk, right? So all these positive integers are distinct, it means they are unique, right? So we have to take the set of these unique integers, we can say. So why? Because if we'll do, let's suppose we have this value, right? If you have n1, right, we will take the power of x, right? Then we have n2 power of x and so on we'll do, and then n2 n3 to the power of x, like that we have n, you can say k, we can take for now. Okay, so if we have these values are unique. Okay, I'm talking about n1 n2 n3 and so on, right, till the nk. So these values are unique, right, unique positive integers, and you can say it's a set of numbers, right? So if you take the set of number from here to here, right, so how many ways we can set this, right, so that if you do the sum it will become equal to n. So how many ways or how many sets of these number n1 to nk we can make, right? Means n1 n2 and so on will come nk. So how many ways these distinct positive integers we can sets, means how many sets are possible, you know the sets, right? How many sets we can make, that if we'll do the power of x we'll get n. I hope you understand. So each integer can be used at most how many times? Once. These integers cannot be repeated multiple times. These should be unique, right? But it doesn't matter, order doesn't matter, because we need to find the many ways, right? There can be many ways, right? So each order doesn't matter here. So let's suppose, for example, we have 1 3, right? 1 3 is equal to, is same as 3 1. Can we say that? So if we'll take 1 3, let's suppose a positive integers, we can take 3 1 also. So we will return the count modulo once we get it, right? So we have to take the modulo also, 10 to the power 9 plus 7 we have to take. So you should think like it's a subset sum problem, right? If you remember, right, some subset problem, right? So if do subset sum problem, right, where these values are nothing but 1 to the power x, 2 to the power x, 3 to the power x, like that will go up to some large value, we can say, right, whose base is nothing but x to the power what we call less than equal to n, right? So this is a kind of that problem, right? Subset problem, right? Subset sum problem, we can say that. So let's understand now the intuition. Okay, what is intuition? So to check intuition, we should think about, let's suppose we'll take n equal to 10, okay, and x equal to 2 that we have given. Okay, so if we want the power, right, power, we'll take 1, 4 and 9. We can take, if we'll take the powers 1, 4 and 9, means 1 to the power, we'll take some value will be there. Okay, let's suppose 3. If we'll multiply 1 into 1 into 1, how many will you get? We will get 1. What about 2? If we'll 2 to power 3, sorry, 2, we have x equal to 2, sorry. Okay, so x to the power 2, so we can say 1 into 1 will get 1, 2 to the power 2 we will get 2 into 2 will get 4, and 3 to the power 2 will get 3 into 3 will get 9. Okay, so when we take n equal to 10, x equal to 4, if we'll do this value will power of 1, 4 and 9, this is a set, right? So if we'll do the power of this, right, we'll get power of these values, right, 1, 2, 3 and so on, we'll get what? We'll get this value. So this is a power set. Okay, what is this? This is a power set, and these are the set value. We can take another set value is what? The unique values are 1, 2, 3. Okay, so the only valid set is what? If we'll take 1 and 4, 1 and 9, right, this will not work. So we can take the value 1 and 3. We can say 1 and 3 are valid set. Okay, because this generates these powers. Are you understanding? Because if we'll do the sum, right, what we will get? This 1 and this 9, if we'll do the sum, we'll get 1 plus 9 equal to 10, which is equal to n, right? That is why we can say 1 and 3 are the valid set. Okay, and so we'll return. This is only one way to make the sum, right? And that is why output is coming 1. I hope you understand, right? Let's understand. If we'll take n equal to 4, another example, and x equal to 1, so what will be the power, right? We can generate power. Let's suppose from 1 to the power 1 is 1, 2 to the power 1 is 2, 3 to the power 1 is 3. Okay, can we take this? We can take this. 4 to the power, we can take 1, it is also coming 4. So the set we have, a set of numbers we have is unique numbers is 1, 2, 3 and 4. Can we say that? But what is the valid sets? There can be many sets, right? So can we say if we'll do this 1, right, and plus 3, very first the set is come 1 and 3, right? Then we can take, can we take only one this 4? Yes, we can take only this 4. So we can say the valid sets is 1, 3 and 4. So there is 2 sets. How many sets are there? 2 sets are there, and so we say this is your answer. I hope you understand. Means how many ways, if you do the sum of these valid sums, it will give you what? It will give you n. It is equal to n. So there is 2 way we can do the sum and we can get the value, right? So these 1, 3 and 4 are the valid sets, and that gives you the answer. I think you are able to understand these examples. Still, if you have doubt, let me know in the comment section. Now think about the approach. Okay, very first, as we have the possible number of ways, the question is saying the number of ways, right? So if we'll apply the brute force, this will become what? Worst. Okay, so very first, to compute again, right, we know we should use some movement things, right? What we can do, either we can go recursive, right, or you can use DFS. So let's suppose if we'll use the pointers, right, in the DFS, movement, right? If we'll apply that, okay, or we can say this, we can say sky recursion, tree. If we will apply this approach, right, where we will use a recursion over index, right? What is the index? Index a power of array, right, that we have seen, and the remaining is the sum. What we will do, we will do the recursion over index and the remaining sum, and we'll find the, let's suppose remaining is 10, index is 0. Let's suppose we'll take remaining as 10. So we'll start remaining at 10, right? Or some index is what is 0. Where index is 0, right, means we'll take 1 to the power what 2. Let's suppose 1 to the power 2, if we are taking, what will come? It will come 1. So if we are taking index is 0, it means what? 1 to the power 0, it is also 1. Any value we are taking the value, it will come what? 1. So this value, we can say, when we are talking about index at 0, means we are talking about this 1. We can say if we'll take index is 0, it's corresponding what? 1 to the power 2, we can say that for now, just for understanding. So what we can do, let me clean. Okay, very first I told you that we are going to use remaining is 10, or remaining is 10, we can say, and idx is equal to 0, I said, right? Can we say that it will give you power 1, right? It will apply this value, right? It will give your power will get 1. Then we'll take this power, right, p equal to 1, and we'll say what is the remaining? Remaining is what? 9. Now increase the index, idx will say 2. How many we will get it here? We'll get p is equal to, we are taking 2, so the value of the value become what? How many? P equal to 9, correct? 2 to the power, if idx 2 will multiply how many times? 2 times, and we'll get p equal to 9, right? Like that, if we'll keep moving ahead, right, sometimes we have to skip also, right? So we will reach some index where, let's suppose, some value will take, and it will give you the value 0, right? The remaining become 0. Some place we will reach where we'll say we have to skip the p equal to 1, right? And it will prune the data, right? Some value, let's suppose 9 is greater than 6, so we'll return that time 0. So it will become little tricky here. Sometimes you have to take it, sometimes you have to skip it, right? So this take it and skip it, like some calculation will happen here also. Okay, means if we have already calculated, if you are already taking somewhere here, we don't need to retake here. Okay, means we want to use DFS, right, or with that DP, because we are using recursion, so we'll use DP also. Okay, if we are skipping here because we have already calculated, like that we can take. So there is always two chances will be there, either we'll take it or we'll skip it. When we are taking p equal to 1, either will take, so let's suppose some value will take, let's suppose p equal to 4, we can take it. Let's suppose p equal to 4 we have already taken, so we have skip it, skip p equal to 4. Similarly, there is many possibilities there that we can see, right, and we can work on that. It means if we are taking any value, let's suppose very first, if we are applying in DFS, okay, so some value I am saying 10 will take, and idx will take, index will take 0. Okay, again if we'll do DFS, we'll get 9, and we'll get idx is equal to 1. So what we will, what we'll do, we have took 1, right? We have took 1, right? Then we have applied DFS again. Let's suppose now remaining is 5. IDX is 2. What we'll say, let's took 4 here, because we have chosen either if here we will take 4 or we'll skip here, right? Either 4 take or 4 skip, and only two chances are there for the DFS. So when we are taking 4, how many remaining is left? Remaining is left 5, right? Now once we have taken 4, the remaining is coming 5, right? When we have skip it, right, what is the remaining? So the DFS will say is 9, because we have skip it, means IDX will increase is 2, right? When we are skipping, right, IDX 2, this time we can take it. Similarly, when we are skipping, the index will remain same, because we have skipped here. Are you understanding? I'm logical, I'm talking, right? Similarly, after this, once you are taking or leaving, right, you will take it, right? Let's suppose further in the DFS you will take 0, where ID remaining 0 and IDX is 3, means we took how many? 9, and we found the value, we got 0 remaining. Then we'll do again the backtrack. What we'll do? The backtrack, right? It's the same thing. We'll apply DFS, we'll do 10, IDX is 1, skip it. Now very first we'll skip it, because we have initially we have not done. Skip 1. Okay, if we skip 1, we'll try the same thing again, and so on will reach to the last. Means if you're talking about the concept, what is the concept is here? So when we take, right, when we take, we move to where? Index plus 1, correct? With some remaining, with some remaining. What is the remaining? We'll just do minus p, whatever we are getting that. If we are skipping, right, a skip will do some move to IDX plus 1, both are same, right, with same remaining. We will not do any minus, with the same remaining will go. Yet we are doing subtracting minus, but here we will do the same remaining. So these two things will do, either take, will skip. What about the pruning? When we'll do pruning, it means what? If p is greater than remaining, right, no need to take, correct? When we are doing pruning, we don't need to take it. It means we can do memorization now, right? Memoization will do. So memoization will cache the data. What will do? It will cache the data result, you can say result data, for what? There will be use IDX and then remaining. So these repeated subtree are reused again and again. Okay, so if you understand the intuition behind this approach that I'm going to use, right, it means here this is a KNAP, or you can say knapsack problem, or you can say subset sum counting problem, right? For each candidate I, where candidate value is I to the power x, where we take it or we skip it. Understand? So if you are aware with 0 by 1 knapsack, right, or the subset counting problem, let me know in the comment section that you know knapsack problem or subset problem, right? Otherwise I'll create a deep dive session of knapsack and subset sum counting problem, right? Either of those I will try, and I'll do the deep dive session there. Okay, let me know in the comment section. So I was talking about the what is the intuition behind this solution, right? Means when we are talking about this type of problem, right, means for each candidate I, what we are going to use? I to the power x we will use, right? Where either we'll take it or we'll skip it. It means we have to pre-computed the power of the base. The float value will take, right, and 1 to the power n to the power 1 by x, right, that we can take, and we'll check how many count ways to reach the remaining. So there are many ways you can solve this problem, that you can use the top-down DFS with the memorization approach that I'm going to use, because I'm recommending this. Okay, you can use the bottom-up using the knapsack style, right? Either you can use the brute approach where no memorization we will use, but I will not suggest, I will not recommend that to use that brute force recursion, right? But if you want to try, you can try the bottom up DFS you can use, and you can use a knapsack style you can use, right? So 1 second. So let's understand how to implement it, right? Very first we have to take the modulo, so we can take the modulo, right, 10 to power 9 plus 7, and this is, we have to take the memo to store the result, right? We have this function given, we have given the n, we have given, and for the power we have given x. Okay, so what we will do, we'll create the memo, we'll initialize the memo n plus 1, n plus 2, we'll create the extra space for current n plus 1, right? So in the DFS, we'll apply the DFS where we'll do the recursion, right, where we'll pass the n, x, and 1. Okay, so this is your current index 1, and x, you know what is your x, this is your remaining. What we will need to do, current index will keep increasing whenever we'll when we are going to take it. So we'll do current plus 1, we'll take it. If we are not taking it, we can say remaining is we are keeping same, but we are increasing the index. Okay, current index will keep increasing that. Okay, means very first we'll check the remaining is equal to 0, return 1, don't do anything, just return 1. Okay, if remaining is less than or greater than this, we'll return 0, because we have to prune the last data. Okay, then current is greater than remaining, will return 0. So these are the base conditions. Whenever we found the remaining is equal to 0, less than 0, or greater, current is greater than remaining, or current is greater than remaining, right, we will return 0. Okay, so these are the base conditions that you can you have to take it. Okay, then we'll check if it is not null, right, means we have calculated this, right? The memo I have already stored the result where we are keeping that. Okay, so we'll return the data from the memory, means we have the cache data, we will return from here. Now you know how to make the power, right? You will add the power, and you will check the power value. If it is greater than remaining, return 0. And these two options that I told you, you take the number or you skip the number, right? That you will do. And just you need to do the plus with the mod, take and skip number of ways we can find, right? And you can store at the on the each index you can store. Okay, I hope you like this video. If you have any doubt in the comment section, please write in the comment section, guys, and I will suggest, please share with your friends, family, if they are preparing for the FANG or product based companies. So try to collaborate with them, and then uh, do the practice. Okay, also support Excel Funda by liking and subscribing this channel. If you have any suggestion, please write in the comment section. Thank you guys, thank you for watching this video.